Hey guys, today we're going to be solving Leetcode question 122, best time to buy and sell stock to. This is the second question in the stock prices problem series. The first problem was the same, except the only difference between this question and the first question is that in the first question we can only do one transaction, at most one transaction, meaning there's a possibility we don't do any transaction at all if the prices are sorted in a descending order. uh, in this problem we can do as many transactions as we like. So this is a classic peaks and valleys question, meaning we are trying to search for local minimas and local maximas and just sum up the differences between them. What I mean by that is, suppose you have something like this. Let's say there's 8 here, there is 10 here, something like this. So the first local minima that we find is 1, because the prices keep dropping, and suppose this was 9. So the first local minima we find is at 1. So what is the first, when would we want to sell this? It would be at 8, right? So that is a local maxima, that is just before the next price drop. So this difference will contribute to the max profit. Now then we will search for the next local minima, which is 3, and then we'll sell it at 10. So basically we're just searching for valleys and peaks. This is a valley, this is a peak, again a valley. Usually a valley has to immediately follow a peak, right? And then this is a peak. So these differences will contribute to the maximum profit. Cool. With that, I think we are ready to code. I'll keep this because first I will present a solution that is based on this valleys and peaks concept, because that comes naturally to me. But one very good observation will lead us to where one very shorter, elegant solution. So I'm going to just keep this around to explain that, because that is a much more elegant solution. Just that it didn't come naturally to me at first, so I want to write what came naturally to me first. Uh, cool. So let's say if so guard is basically just an if to see that the I'm just trying to ensure that the prices array is not empty. For people not familiar with Swift, this is simply that, nothing, not as fancy as it looks. um, cool. So I'm literally going to be searching for valleys and peaks, because this makes more sense to me that shorter solutions. We'll keep a max profit variable. We'll keep an I variable to traverse the prices array. So while we haven't reached the end of the prices array, let me just insert the return statement. Okay. So let's search for the let's search for a valley first. So we'll don't worry. Like this looks like we have nested while loops, but we are basically just going to be iterating the prices array once, so it will still be an order n solution. So keep traversing it until the prices don't drop. So basically we will exit this loop when we find the first price drop, and that will give us our new valley or new local minima. Now that we have the local minima, we will start searching for the local maxima. that will be accomplished. So we'll keep so we'll keep searching, traversing the array until we see a price. I mean, we'll keep searching until there's a price drop, until the first price drop, meaning the next valley. So just before the next valley, if we stop, that will give us the peak. Now that we have found our peak and valley, we simply add it to the max profit. Please note that there's a possibility we have zero profit, which would refer to the situation where all the stock prices are given in a descending order of values, meaning the stock price never rose, so can make no profit. So we'll just return zero max profit in that case, minus valley. Yeah, so basically we still have to increment this I, right? Okay, let's see if it works. Yay, works. Cool. So this is this is an acceptable solution. This looks scary with so many while loops, but what I ensure you, since we'll only be iterating the prices array once, we'll only inspect every value once. So it is still an order n solution. I promised you a more elegant solution. This arises from the fact that if you look at the problem, you're only just adding up the positive segments, only the segments where the price is going from a lower value to a larger value, literally. Throughout the array, ignore that these are stock prices, whatever. You're only just adding up positive segments for this solution. So, what I mean by that is, if you look at this array that I gave you initially, what are positive segments? Meaning 1 to 5 is a positive segment, we can add that. 5 to 8 is a positive segment, we can add that. 3 to 6, meaning whether in a first value is a low value and the second value is a larger value, that is a positive segment. 6 to 10 is a positive segment. We won't add 10 to 4. That is basically what we are doing. And if we look at the problem that way, it gives us a very easy, very clean and neat solution. Just that it didn't come to me naturally the first time, so I didn't present it right away. But it's such a small solution and such a beautiful solution that I'm just going to code it for you once again. um, so if prices dot I is greater than prices of I minus 1, basically if this is a positive, forgot to initialize max profit, if this is a positive segment, this definitely adds to the maximum profit. And yeah, that's it, guys. Looks great, doesn't it? Works. Wow, awesome. Cool, guys. This is again an order and solution, adding up all positive segments. Cool. Good luck, guys. Thanks for watching. Bye.